Hi students, 11th standard chemistry, quantum mechanical model of an atom, unit 2. So in the last class we have covered the principal quantum number and azimuthal quantum number, and this class we will try to complete the magnetic as well as spin quantum number. What is magnetic quantum number? Magnetic quantum number represented as ML. Okay, this magnetic quantum number describes the orientation of the orbital in space. This magnetic quantum number describes the orientation of the orbital in space. Okay, this magnetic quantum number ML has some values. What are all the values they have given here? ML is equal to minus L2 plus L. Okay, which means minus L, 0 and plus L. Okay, so I have written ML here, which indicates this L, which is nothing but the azimuthal quantum number. So this magnetic quantum number depends on the azimuthal quantum number. The magnetic quantum number values depends on the azimuthal quantum number values. So I have written the values of azimuthal quantum number. Last class itself we have seen the value of L 0 to 3 we have seen in the last class itself. So I have written the azimuthal quantum number values. Now I am going to calculate the magnetic quantum number values by using this. Okay, so magnetic quantum number is represented as ML. So ML, L is equal to 0 means ML also is 0. Okay, then L is equal to 1 means I have written here L, which is nothing but the azimuthal quantum number. What is the value they have given? Minus L2 plus L. So L value is 1 here. So I have to write minus 1 to plus 1. So let me write the values of magnetic quantum number. So minus 1, 0 plus 1. Is it clear, students? I have to substitute the values for L here. Okay, if L is equal to 1, I have to substitute 1 here. Then if L is equal to 2, in the place of L I am going to write 2. Okay, so let me write the values. ML is equal to, L value will be 2. So in the place of L I have to write 2. Okay, so minus 2, minus 1, 0 plus 1 plus 2. Okay, so this is the magnetic quantum number values for if L is equal to 2. Then I am going to do it for L is equal to 3. Okay, if L is equal to 3 means in the place of L I have to write minus 3 up to plus 3. Okay, so let me write the values here. ML is equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay, this directly indicates the orbital. Okay, say for example L is equal to 0 means S orbital, and L is equal to 1 means P orbital. P orbital is having 3 degeneracy set. So this will be indicated as 0, minus 1, plus 1. If L is equal to 2, the values will be, we are having the 5 values. This indicates the d orbital. If I draw the degeneracy set, I will have 5 sets, 1, 2, 3, 4 and 5. The values will be minus 2, minus 1, 0, plus 1, plus 2. Okay, this is the d orbital, this is S, and this is P, and this is d orbital. And if L is equal to 3 means I will have 7 values. Okay, I have to write 7 degeneracy set. Okay, let me write the values here. Minus 3, minus 2, minus 1, 0, plus 1 plus 2, sorry, minus 3 minus 2 minus 1 0 plus 1 plus 2 plus 3. I am having 7 degeneracy set here. Okay. So, this indicates the f orbital. Already we have studied the maximum number of electrons which is present in each orbital. If it is s orbitals, what is the maximum number of electrons will be present? Only 2 electrons, or otherwise 2 electrons can accommodate in s orbital. If it is p orbitals, how many electrons can accommodate? 6 electrons can accommodate in p orbitals. If it is d orbital, totally I can have the 10 electrons can accommodate in d orbitals. If it is 7 f orbital, means totally the 14 electrons can accommodate in f orbital. Okay. This is the basic that we have seen already. Okay. This magnetic quantum number explains about one important effect. What is that? Zeeman effect. It is very important question that you can expect this question for your exam too. Okay. What this effect says? Zeeman effect, which is nothing but the splitting of spectral line in the presence of magnetic field, is called Zeeman effect. What is that? The splitting of spectral lines in the magnetic field, in the presence of magnetic field, is called Zeeman effect. Okay. So, this magnetic quantum number will have the experimental evidence for this Zeeman effect. Okay. Is it clear for everyone? So, up to that we have completed the magnetic quantum number. Then we can go for the spin quantum number. Okay. So, the spin quantum number shortly represented as ms. Here I have explained, here this magnetic quantum number values depends upon the azimuthal quantum number value. In the same way I have written here ms. So, the spin quantum number values depends on the magnetic quantum number value. Okay. So, this spin quantum number describes the angular momentum of an electron. This describes the angular momentum of an electron. Say for example, each orbital can only hold 2 electrons. Okay. This is called a degeneracy set. So, let me write here, this is S and this is p orbital. S orbitals means it can have only 2 electrons. P orbitals, it can have the 6 electrons. Okay. In order to explain the spin quantum number, I have drawn the degeneracy set here. Okay. Each orbital can only hold 2 electrons. Okay. Since it is an orbital in the sense, it can have the 2 electrons. These 2 electrons will have different spins. Say for example, if it is like this, means it will have the plus half spin and another one will have the minus half spin. Okay. This already we know that, even though I am explaining, if one degeneracy set contain 2 electron, means one electron will have the positive spin and the other electron will have the negative spin. Okay. So, in this way I have to write for p orbital, d orbital and f orbital. Okay. In order to understand this, you should know this what is spin. Okay. First, the electrons will fill like this. Afterwards only the pairing can take place. Okay. First, the electrons will fill the available orbitals, even spins. Okay. When it is filled like this, it will have the positive half. This also will have the positive half. This also will have the positive half spin. Then only what will be taking place? Then only the pairing will be taking place. So, that time the spin value will be changed, plus half and minus half. Okay. So, until all the available orbitals is filled up first, then only the pairing can take place. Okay. So, in this topic you should give importance to the spin. Okay, plus half and minus half. Plus half in the sense it can rotate the clockwise direction, and the minus half means it can rotate the anti-clockwise direction. Thank you.